Hello class, today we're going to talk about quadrilaterals, polygons, and angles. This is section 12.1 D and E. A quadrilateral is a geometric figure with 4 sides and 4 angles. If we are looking at the angles, all of them should add up to 360 degrees. There are a few specific quadrilaterals that we're going to look at. You're going to want to take a minute and pause the video and copy down this information into your notebook. Parallelogram. This figure in the middle is an example of a parallelogram. The opposite sides are congruent, so top and bottom, left and right, are congruent. The opposite sides are parallel, so top is parallel to bottom, they'll never touch. Left is parallel to right, they'll never touch. And then our opposite angles are congruent. So these two on the diagonal and these two on the diagonal are the same size. Looking at a rectangle, we have some of the same qualifications. So those opposite sides are congruent, top and bottom, left and right. They are also parallel. The difference is that in a rectangle, all 4 of the angles are congruent, which means they are all right angles. Then we jump down to the square. All of our sides now are also congruent, as well as all of our angles. Top and bottom, left and right are still parallel. Then we come back out to a rhombus. We still have our 4 equal sides, but now our diagonal angles are equal again. And then we still have parallel on the top, bottom, left, and right. And trapezoid just has one set of parallel sides. So top and bottom, if I took and shifted it onto its side, it could also be parallel left and right. So we're going to classify the quadrilaterals. We want to be as specific as possible. Looking at this top one, we have 2 pairs of congruent sides, 2 pairs of parallel sides, and all 4 angles being equal. So this top one is an example of a rectangle. Coming down to the bottom, we've got 4 equal sides, 4 equal angles, and 2 sets of parallel sides. So this bottom one is an example of a square. So you're just going to have to look at that chart and reference back and forth to determine the best option for naming. When we're finding a missing angle, very similar to what we did with the triangles yesterday, the first thing you're going to do is add up all of your given information. So 146 plus 116 plus 40. When I add all of those up, I end up with 302. Then, since a quadrilateral adds up to 360 degrees, I'm going to take 360 and subtract 302, which is going to give me 58. So that means the measure of angle X is 58 degrees. So we take and we want to make sure that they add up all the way to 360 degrees. Same kind of idea occurs here, but now we need to pay attention to the specific shape we are looking at. Notice I've got parallel sides going on here, and I've only got 2 angle measurements. When you are given this information, you are going to assume that it is a parallelogram and that these opposite angles are congruent. So if you're missing 2 angles, you're going to want to look at it to see if it is a parallelogram. So angle X is opposite or across from that 48 degrees. So that means angle X is 48 degrees. Angle Y is across from 132, which means angle Y is 132 degrees. Next, we're going to talk about polygons. These are simple closed figures that have 3 or more sides. Simple means that the sides do not cross each other. So this over here, this hourglass looking shape, that is not simple because these 2 lines cross over each other. Then we've got closed, which means there's no gap in between these sides. So this second example is not a closed figure. These last 2 non-polygons are not polygons because they are curved. A curved line is not a side, so it does not count when we are counting sides. All of these examples on the left are types of polygons. We've already talked about the first 2. Number of sides, if it was 3, it's a triangle. If it's 4, it's a quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is a heptagon. 8 is a decagon. 9 is a nonagon. 10 is a decagon. So pentagon, hexagon, heptagon, octagon, nonagon, decagon. So when you're classifying polygons, first you want to make sure it's simple, so nothing's crossed over each other, which is good. Closed, there's no gaps, which is good. And then not curved. That's good. So now we're going to go ahead and count the number of sides. 1, 2, 3, 4, 5, 6, 7. Since we have 7 sides here, we have a heptagon. If I come over to the second one, there is a curve in the shape, so we would say not a polygon, and then you would give a reason why. In this case, you would say because it's curved. So if it is not a polygon, you want to tell me why. If it is, you want to give me the name. Another thing we need to know about polygons is there is a way to figure out what the angle sum is. So how to add up and figure out the total number of degrees of a shape. The equation for this is S is equal to 180 times n minus 2. The n is the number of sides of a polygon. So for example, if I had a triangle, I plug in 3. 3 minus 2 gives me 1. 1 times 180 is 180, which is how much a triangle adds up to. Quadrilateral would give me 4 minus 2, which is 2, times 180, which is 360. That's how much a quadrilateral adds up to. Now your job is to try to figure it out for pentagon. So there are 5 sides in a pentagon, so that means our n value is going to be 5. So I'm going to say S is equal to 180 times 5 minus 2, which gives me S is equal to 180 times 3. So S, the sum of all of my angles, is 540 degrees. 180 times 3 is 540. Sometimes the polygons do not have a specific name, but they are telling you how many sides there are. So for example, a 15-sided polygon, you could also see this written out as a 15gon. That's the shorthanded abbreviation for this. In this case, we still use that same formula, so S is equal to 180 times 15 minus 2, which gives me S is equal to 180 times 13. So our angle sum is going to be 2,340 degrees. Now that you're done with the video, show the notes to your sub and get your homework slip.